Hello, I welcome you all in this course on mechanical measurement systems. Today we will discuss basic concepts of measurement, and in today's lecture we will cover the concept of measurement, fundamental units, application of measurement. So anything which is existing in this universe is existing in some amount. For example, distance. Distance is existing in some amount. Mass is existing in some amount, temperature is existing in some amount. So these units have to be measured. I mean, if we want to compare one length to other length, so both the lengths have to be measured. And there are different units of measurement. They can be measured in terms of meters, they can be measured in terms of centimeters, they can be measured in terms of feet. In fact, your hand can also be a measuring tool. So the process of measurement is compare a parameter with a known standard. As you must have studied at the school level, there are three fundamental units: units for mass, unit for length, and unit for time. Your hand can be a unit for length, but the distance, so this length may vary from person, it shall vary from person to person. So therefore, there has to be some standard length, there has to be some standard meter for the act of measurement, there has to be some standard mass for the act of measurement, there has to be some standard time for the act of measurement. So there are certain systems. Out of those systems, very popular system is MKS systems, because these units are known as fundamental units. There are two types of units: fundamental units and another one is derived units. Units derived out of these units are known as derived units. For example, speed. Speed is meters per second, it is a derived unit. Acceleration, meters per second square, it is a derived unit. So there are certain systems for measurement like MKS system, then there is a FPS systems. In MKS system, the unit of mass is kg. Sorry, the unit of length is meter. This is length, mass and second. So we will replace this length by mass, L M. So length is meter, this is kilogram and this is second, MKS unit. FPS unit, foot pound second. There is another system which is known as CGS system, which is not very popular nowadays. This is length, for length it is centimeters, G is mass, for mass it is grams, and S for seconds. So you will find that for time, in all these three the unit is seconds. For mass it is varying. So FPS system is also known as inch pound system nowadays, IP system, inch pound system. But for many years we have been using this MKS system in India, but now we have switched over to SI system. In fact, India and Europe, the SI system, International Standard System, is followed, which is close to the MKS system. And in US, they normally follow the inch pound system. So as a mechanical engineer or any engineer of any other branch of engineering or graduate of any other branch of engineering, you should be well conversant with the conversion of units from one system to another system. So you should be very comfortable for converting units from one system to another system. Now we will start with the standards. Standard for length. What we will call a standard for length. Earlier, the standard of length was the distance or the length of the rod. There was a platinum iridium rod in International Bureau of Weights and Measurements in Paris. So length of that rod between 2 points was considered 1 meter length. But now this standard has changed. Now the 1 meter length is the distance traveled by light in vacuum in 299792458 seconds. So this distance is 1 meter length as per the international standards. Standard for mass. Standard for mass is the same. Mass of this rod between these 2 points, or the mass of this rod is standard mass of 1 kg. It is remaining same, 1 kg. And standard for time. Earlier standard of time was derived from the relative movement of sun and the earth. Nowadays the standard of time is the time period of cesium-138 atom for number of vibrations 9, 192, 631, 770. So for this number of vibrations, the time consumed is 1 second. So this is the standard of time nowadays. But now, because these are old fundamental units, now more units are added into these fundamental units, and one of these units is ampere, measurement of current. And in order to define 1 ampere, we say that it is the amount of current, which is passed through parallel conductor in vacuum having cross section area tending to 0 and force per meter length is 2 into 10 to power minus 7 newtons per meter. If this much force is exerted, electromagnetic force is exerted, then we will say that the amount of current is 1 ampere. So this is a new fundamental unit, current. There are other fundamental units also which are, because these units cannot be converted to each other. Say length we cannot convert to mass, mass we cannot convert to time, ampere we cannot express either of L, M or T, right. So this is new fundamental units. Another fundamental unit is the unit of temperature, which is considered as Kelvin, right. And the reference point for the Kelvin is, the triple point of water. Now triple point of water means it is the pressure and temperature at which the water exists in solid, liquid and gaseous form, and the temperature of this triple point of water is 273.16 Kelvin. Now another fundamental unit is the unit of light, candela. Because the light, intensity of the light cannot be expressed with either of these. So candela is also, because, and we have to frequently use in engineering application, we have to frequently use the intensity of light either in candela or lux or lumens, and lux and lumens are related. Lumens are lux are lumens per meter square. So candela, so the lumens is equal to candela multiplied by steradian. So first of all we will define what is candela. Candela is the intensity of a source that emits the monochromatic light at 540 into 10 to power 12 hertz, and radiation intensity is 1 by 683 watts per steradian. So this is 1 candela. This is the frequency of the radiation and this is the power of radiation. If this frequency, monochromatic frequency, and with this power is known as 1 candela. So 1 lumen is equal to 1 candela multiplied by, 1 lumens is equal to candela multiplied by steradian, and 1 lux is equal to 1 lumens per meter square. So I'll give you an example. For example, in this room, the intensity of the light may be of the order of 700 lux. If you go outside, the intensity of the sunlight is more than 10,000 lux. And higher the intensity of the light, brighter will be the surroundings. So this is about the units of the measurement. Now what is the use of the measurement? The issue is, what is the use of the measurement or what is the application of measurement? First of all, with the help of this process of measurement, we get idea about the phenomena. For example, there is a boiler, but I do not know how much pressure is inside the boiler. So I have to fix a pressure gauge. So pressure gauge is an instrument. So instrument is a media for measurement. So instrumentation and measurement, they go together. They cannot be separated out. So there are two things: instrumentation and another thing is measurement. In fact, our entire life is filled with the instrumentation. After certain time, we just look at our watch. So this is also an instrument for measuring the time. We move on motorcycle or in a car, speedometer is an instrument, right? If you go to the industry, different type of pressure gauges, thermometers, they are all instruments. So without instruments, the industries cannot survive. Without instruments, our day-to-day life, it is difficult to survive. So the requirement of the measurement is, first of all, to understand the phenomena, to monitor the process. Suppose I want to boil water at 500 degrees centigrade. So in order to boil water at 500 degrees centigrade, I must have a thermometer to measure the 500 degrees centigrade temperature. So the process monitoring is also done with the help of measurement. Second thing is control of the process. Once we know that the water is boiling at 500 degrees centigrade, the pressure should not exceed. So pressure gauge will be fixed. It will be used for control of the process. If the pressure exceeds, we will vent off the steam. So the pressure is maintained constant. So not only monitoring the process, the act of measurement is also used for controlling the process. Second thing is, the data are also required for engineering analysis, right? And for that purpose also measurements are required. So in this course, in subsequent lectures, we will be focusing on the characteristics of the instruments also, and we will be discussing in details with different type of instruments and different type of measurement processes. Characteristics of the instrument is also important. For example, I want to measure the current, right? And the voltmeter is sluggish and there is a momentary flash of the current. So by the time the needle is deflected, the current will go off. So I will not be able to make the correct measurement of the current. That is why the response of the instrument is also important. But if the instrument is oversensitive, in that case also the oscillations will take place. All these things we will discuss in the subsequent lectures. Now I will focus on conversion of units from one form to another form, which is very important for any engineer. For example, mass. There is a popular unit, pounds. So a pound is approximately 0.4534 kgs. a pond, because we are familiar with the kilograms only, or 2.2 kilograms approximately makes 1 pond, right? In a pond, there are 16 ounce. In a pond, there are 7,000 grains. Though these units are not being used nowadays, but we must know, as an engineer, we must know. 25 ponds is 1 quarter. But nowadays, mainly we are focusing with kgs only, kgs or tons, right? If the mass is very large, then we express it in terms of tons. Now, there are two types of tons. One is TON, another is TONNE. Both are not same. This TONNE is metric ton, and it is equal to 1000 kgs. Right? Now this ton has, again, it is in two parts. Imperial ton is 1016 kgs, and US ton, that is 2000 pounds. So when we are dealing with the ton, we have to be very careful whether we are, dealing with metric tons, imperial ton or US ton. Similarly, length. For length, meter is used, and for a larger distance, kilometer is used. Earlier, the unit of the distance was mile. If you remember, the unit of the distance was 1 mile. 1 mile is equal to 1760 yards. Or it is, if you want to express in terms of kilometers, 1.61 kilometers. Right? And there was another popular unit which was furlong. 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 So 1 furlong, so 1 mile had 8 furlongs. So if you divide this by 8, you will get 220 yards. So 1 furlong is 220 yards. Sorry, 1 furlong. 1 furlong is 220 yards, and 1 furlong has 10 chains. So 1 chain is equal to 22 yards. That is the length of the cricket pitch. So I was always wondering why it is 22 yards, why it is not 20 yards or 25 yards. The reason being, in those days, this MKS or these type of units were not, these units were existing, and it was considered that perhaps, this is my opinion, that it was considered that the cricket pitch length should be of 1 chain, that is 22 yards. In addition to that, there is a unit of rods also. So 1 mile is 320 rods, or 260 ropes. So these are old units, right? And but nowadays we are following SI system, we are following meters, kilometers, but we have to be conversant with these units also. And there was a nautical mile also in those days. Now still it exists. Nautical mile is the distance, because Earth's surface is curved, right? And when the ships are sailing, they are not sailing on a plane surface, they are sailing on a curved surface in a larger perspective, right? So the distance travelled for a latitude, on a latitude, for 1 minute angle on the center of the earth is 1 nautical mile, and 1 nautical mile is equal to 1.1508 mile or 1.852 kilometer. So that is the distance of nautical mile. Now, in addition to the length, area of the surface, nowadays it is expressed in terms of meters or airs or hectares. 1 air is 100 meter square air. 1 hectare is 100 into 100 meter square. That is 1 hectare. In earlier days, the area was expressed in terms of acres. Now 1 acre is 4840 yards square. 4840 yards square or is equal to 40.468 acre. Sorry, air. 40.468 air is 1 acre. Now gallon. Now volume. Now from area we will come to the volume. Volume we normally express in terms of meter cube or liters. So 1000 liters together they make 1 meter cube, right? But in some other units it is also expressed in terms of gallons, and there are 2 types of gallons, the gallon of UK and gallon of US. The gallon of UK is approximately 4.5461 liter. Now gallon of US is 3.7854 liters. They are substantially different from each other. So gallon of UK, gallon of US. Similarly, barrel. There is another unit of the volume is barrel. Barrel. Now US barrel is 119.24 liter, and UK barrel is, or we'll write here UK barrel first. Okay, UK barrel is 163.66 liters. And US barrel is 119.24 liters. There is another barrel which is known as oil barrel. So 0.75 US barrel is equal to 1 oil barrel. So oil barrel is 158.987 liters. So oil barrel, 75% of the oil barrel is US barrel. So these are, I mean, units which are still frequently used in international market, and as an engineer we have to be conversant with these units. The unit of pressure. Pressure, atmospheric pressure as we know is 1.01325 bar or 101.325 kilopascal or 1.0332 kilogram force per centimeter square. Now this kilogram force per centimeter square, in many of the industries you will find the pressure gauges which have pressure expressed in terms of kilograms force per centimeter square. So you should be very convenient in converting this into this form, right? So if I want to convert this into kilogram force per centimeter square, so 101.325 kilopascal. So it is 10 to power 3, and divided by 9.81, because this is in centimeter square, this is 10 to power 4. And if we solve this, we will be getting this expression, right? And 1 bar pressure, 1 bar is equal to 10 to power 5 newtons per meter square or 100 kilopascal. Now 1 bar is equal to 14.5 psi. Now in the industries you will find there are number of pressure gauges which are expressing the pressure in terms of pounds per square inch. So 1 bar is equivalent to 14.5 pounds per square inch, and this is the gauge pressure, because the normal mistakes while doing the measurement, when we measure the pressure with the pressure gauge, we consider gauge pressure and absolute pressure. So always add atmospheric pressure into the gauge pressure, and that will give you the absolute pressure in the vessel or any other confinement. There is another unit for heat or heat transfer, that is British thermal unit. When you go out to purchase your air conditioner, or if you purchase, let us say, 1.5 ton air conditioner. So 1.5 ton air conditioner, they say, they don't write normally in the data, in the data sheet, they don't write 1.5 ton, they write 18,000 BTU per hour. 18,000 BTU per hour is 1.5 tons of cooling or 3.5 kilowatt of heat transfer. So if we convert BTU into joules, so BTU to joules, so 1 BTU is equal to 1055 joules. So by using this conversion, you can convert BTU to the joules. In addition to this, mass, length, time, dimensions, I will try to tell you one interesting thing. If you look at the A4 size paper, if you look at the A4 size paper, and if you fold the A4 size paper, you will be getting the same aspect ratio. If you further fold it, then again you will be getting the same aspect ratio. The reason being that the ratio of these two arms is under root 2. So this is A, this is under root 2A. So the moment you fold it, this becomes under root 2A by 2 or A by under root 2, longer this arm, and this remains A, and this becomes longer arm, and the ratio is again under root 2. If you further fold it 4 times, right, so then it becomes A by 2. So A by 2 and A by under root 2. So ratio will always remain, this is known as Silver ratio. And when we say the AO square, AO size of paper, A0 size of paper. So A0 size of paper is that paper which has area 1 meter square, and the ratio of A and B, B by A is under root 2. If we fold it once, it becomes A1. If we fold it twice, the size becomes A2. If you fold it 3 times, A3, and then 4 times, then it becomes A4 size. So that is all for today's lecture, right? In the next class, we will start with the introduction to the instrumentation.